In today's presentation, we will be talking about running Windows workloads and .NET applications on AWS. I'm Kevin Epstein, the Head of Solutions Architecture here at CorpInfo. I've spent most of my career in enterprise IT organizations and have built and managed global networks and data centers. Over the years, I have been through the transitions that many of you would have experienced of on-prem to colo hosting, both with physical and later virtualized infrastructure. About 6 years ago, I started realizing that cloud was going to be a game changer for how most businesses would consume and use computing resources, and decided to focus in this area, helping customers like you take advantage of the cloud. Also with me today, we have Taylor Bird. Taylor is the head of Enterprise Cloud here at CorpInfo and has been working on public cloud projects for over 7 years. He is highly experienced on the Microsoft .NET platform. Taylor holds multiple AWS certifications and has focused his work on large enterprise-scale cloud deployments. In working with many customers, we have realized that there are a couple common misconceptions around running .NET in the cloud. There's a view at a high level that because Visual Studio and .NET are Microsoft products, that they must then naturally fit and run better with Microsoft. But in our experience, this is not the case, and AWS provides fundamentally stronger and more stable operating experiences for these workloads. The second misconception is that if a customer is embedded within the Microsoft ecosystem and using tools such as .NET Visual Studio and programming languages like C#, that their businesses will face too much disruption and too much change to the development process. Again, this is not true, and we'll show this during the demo with Taylor. I think that you'll see that the development process can actually be simplified in many cases. We've engaged in over 50 in-person lab sessions across the country where our engineers have taught developers to go from no experience with the cloud completely from scratch to deploying a .NET application in 90 minutes using some simple automation. The idea is to build automation pipelines that are simple and therefore scalable. To begin, we wanted to show you how your tools and workflows might change as you make the move from on-prem to AWS. Inside your existing data centers today, you're building and managing your .NET environments with tools like VSTS, TFS, and probably a healthy amount of PowerShell. As you move to AWS, the takeaway that we'd like you to see is that we don't take away these tools from you. Rather, you have all the same tools you used before, and then you get a bunch of services and tools from Amazon to make extending your current automation pipelines easier and faster. To begin with, there's Toolkit for Visual Studio, which allows a developer to navigate the AWS environment directly from the Visual Studio IDE. There's AWS Tools for PowerShell, which gives you direct access to the AWS services from within your PowerShell scripts. And then there's AWS S3, which you might use to stage deployment payloads, and AWS CodeDeploy, which is going to be a game changer in how you deploy code to your autoscaling groups. Then there is Lambda, which is an incredibly versatile tool in your development workflow, specifically because it's ideal for running single-purpose, discrete bits of code in reaction to events. And of course, we will always have CloudFormation, which will help you deploy your infrastructure. Amazon has spent a lot of time and energy building tools and services that help .NET teams move from the development stages of a project all the way through to production rollout. Visual Studio Toolkit allows developers to manage AWS resources directly from within the IDE. Code can be checked into TFS, VSTS, or if you want to embrace services that Amazon provides, you could use CodeCommit. The native SDKs allow .NET developers to consume Amazon services directly from their code. Using these tools, it's now easier than it has been in the past to build and deploy applications and services that are scalable, secure, and highly performant in much less time. Many of the AWS tools help developers focus on what's important to them, their code. Developers can spend more time writing code while, in many cases, AWS abstracts away some of the complexities of managing infrastructure. A couple good examples of this might be AWS CloudFormation, which orchestrates infrastructure, or Elastic Beanstalk, which is a service that allows developers to simply upload application code, and Beanstalk will manage the requirements behind the scenes to deploy the workloads. Beyond abstracting away infrastructure complexities, the cloud brings new capabilities to developers. AWS Lambda allows us to run serverless code. Here again, the .NET community are treated as first-class citizens, with the .NET Core being one of the languages supported by Lambda. Probably one of the most important features, though, in our opinion, and echoed by many of our customers, is that there is massive community support for the platform. As mentioned a few slides ago, the AWS Toolkit for Visual Studio really gives the developers a fully integrated experience. They can deploy or manage services such as EC2 or RDS, or they can publish Lambda functions directly from within the IDE. Of course, they can always use tools such as VSTS, in which case the developer experience is equally rich in that their workflows are still driven from the IDE. Using AWS's SDKs for .NET, developers can build applications and services that integrate directly with the AWS platform. The SDKs are feature-rich and are now very mature. The documentation for the SDKs is excellent, and there are a lot of example code snippets to get you started and help you accelerate your application development. All of the SDKs are available through NuGet. So far, we have mostly spoken about what AWS provides us as developers, but of course we do still need to manage and deploy infrastructure onto which our code will be deployed. We already mentioned CloudFormation, and it's hard to overstate just how much of a game changer it is to be able to express your infrastructure as code and have your CloudFormation templates also checked into your source code repositories. In much the same way as we use VSTS to deploy application code, we can use it to also test and deploy our infrastructure using CloudFormation. Up until now, we have been focused on the Microsoft and AWS tools available to you. What we shouldn't lose sight of, though, is that there's a vast ecosystem of other tools out there that you can also take advantage of, and that, in many cases, they may be more appropriate to the job at hand. Today, we are spoiled for choice, and it's up to us to make the best choice for our circumstances. For example, you may be very happy using GitLab for your source code repository needs. There's no reason you should change that. Also, if you prefer something like Jenkins for your automated testing and building, you can absolutely continue to do that. And whether you're a chef or puppet shop, there's going to be a place in your workflows for these tools once you've migrated to AWS. Sometimes, however, you don't always have the right tool out of the box. In these cases, you can always build the integration you need, and this is where Lambda really shines. Lambda can be an excellent choice in these scenarios because it's event-driven, and the Lambda function is very specific to one task. The sample code on the slide shows a fully functional C# Lambda function. All it does is return an input back to us in uppercase. The point, though, of sharing this example is to show how simple it can be to start integrating Lambda into your build and deployment workflows, but also you should start thinking about Lambda as a viable solution to your production workloads as well. Traditionally, one of the more notable differences between Microsoft environments and the open source communities was that the open source communities had a massive amount of support. What we're now seeing is that the .NET teams now have the same level of support. Amazon has delivered incredibly detailed documentation for the platform as a whole and the .NET SDKs. There's also very active forums, which you'll often find exactly the question you had being asked and answered. Extending the online support system is the Amazon Support Center. There's a couple different ways you can engage Amazon, and in many cases the teams are supporting the Microsoft product itself. Take, for example, SQL Server on RDS. SQL Server is a Microsoft product, but because it's delivered as a service, Amazon will actually support the SQL Server needs. Just before we head into the demo, we want to share with you a quick case study. When we met Edwards Lifesciences, they were ready to migrate to the cloud and weren't fully sure how they'd get started or how it would turn out. We started out with a very traditional lift and shift migration of about 1,000 servers, including some very large SQL servers that supported their JDE environment. What unfolded on the back of that migration is that Edwards started asking us to help them automate their code deployment workflows. We continue today to be engaged with them on their journey to more automated development and deployment workflow. I encourage you to take a look at the case study on our website for more details. Now, I'll hand off to Taylor, who is going to walk us through the demo.
And I want to take a little bit of time today to talk about some of the tooling available to .NET developers and .NET teams in AWS, as well as Through a simple demonstration, kind of show how those tools can be combined with AWS Platform Services to create a continuous integration workflow that's very seamless and using a lot of the tooling that's already in use today to get code directly from your VSTS environment onto AWS infrastructure. So to kind of outline what we want to do in our demo, just a very simple workflow of getting code from a developer all the way through the team environment to AWS. We're going to have a workflow where a developer is working in Visual Studio, checks in his or her changes, pushes those changes to a TFS or a VSTS service. And from there, a TFS build is going to kick off. It's going to push that build up into S3, and then it's going to use AWS Lambda to signal to AWS CodeDeploy that that deployment is ready, and to actually push that out to Amazon EC2 infrastructure on a auto-scaling group fronted by a load balancer. Before we start the demo, I want to briefly talk about some of the tooling available to .NET teams from AWS. Starting with the AWS Toolkit for Visual Studio, this provides an IDE plugin to the Visual Studio environment, which enables you to manage and interact and control a variety of the AWS services directly from the IDE without having to switch over the console or integrate with the command line interface. So from here, you can interact with EC2, S3 buckets, a large variety of anything you might need to do, especially from a development and developer experience while code is being built and you want to interact with these services very quickly. Next would be the AWS Tools for Windows PowerShell, which is a complete library of commandlets that wrap the AWS APIs and allow you to interact with all the core services directly from PowerShell, which can be easily integrated immediately into any DevOps scripts or automation scripts or software development scripts that are already in place today. Next would be the AWS SDK for .NET. AWS provides a complete SDK that wraps all core API functions, as well as some higher level abstraction libraries for certain tooling to enable you to integrate with AWS services immediately today from your application code without learning new languages or implementing new platform. The complete SDK is compatible with the .NET framework and latest versions of .NET Core, and is all published and kept up to date and available in NuGet. So you can begin using it today just like any other external library. And lastly is a new addition, the AWS Tools for VSTS and TFS, which provide a series of extensions to TFS servers or VSTS installs that enable you to interact with AWS services directly from TFS builds or TFS release management in a native way, enable you to do things such as pushing a new .NET function up to Lambda, signaling CodeDeploy, uploading files to S3, and a variety of other deployment and release related tools. So you can use the tools you use today without any custom integration straight out of the box to begin using the AWS platform. To get started, we want to take a very simple .NET web application, ASPNET MVC. The main thing I want to show about this is that there's nothing terribly special about this application. Nothing's been done to it to make it work or compatible with AWS. There's a few files we've added to make it compatible with AWS CodeDeploy, but these files just output to the build. This solution can be compiled and pushed to an on-premise server farm, to developer workstation, etc. So there's nothing terribly different about it. We haven't wrapped it in anything to make it work in AWS. And just launching it, want to again show there's nothing terribly special. This is a very simple application. A logo, a header, a table, some data load, sort of representative of a typical line of business application, but obviously could be extrapolated into any complex .NET solution. Now this application is ready to go. It can be deployed today to AWS using a variety of different techniques, external deployment libraries, copying it to the server, even pushing it to Beanstalk directly from the toolkit. But we want to show in this demo how the tooling and the platform supports a team environment. So to do that, I actually want to show the same application from a VSTS system. So I'm going to go ahead and close this solution and connect up to my VSTS server. So find my server. Go ahead and pull latest. And open the solution. So exact same web app solution, just pulled from VSTS, so we're connected to source control. From here, just to illustrate our changes as we go through this deployment, I'm going to add something we can just kind of visually look at. So I'm going to modify the footer and just add a version number, just a V1, so we can see a change flow through the environment. So I'm going to go ahead and check this change in. So commit, leave a little note, commit and push. That change will go up. There we go. Now going over to our VSTS, I want to check the code history just to show that our change has gone up. Let's go into history, and we can see that, yeah, our change 5 is in fact there and ready to be built. So next we're going to go ahead back to Visual Studio and kick off a build. All right, go ahead and queue that up. And we'll see that starting. Now, while that runs, I want to go to our build definition and kind of talk about the integration steps we've taken for this solution. I'm going to go over to our build definition, edit, and just illustrate again. This is fairly out of the box. We're going to do a NuGet package restore, compile the solution, prepare the output. From there, we're just going to modify the output a little bit, put it into a zip file, and then we're going to use 2 extension tasks to push it up to Amazon S3. And actually trigger CodeDeploy, but via AWS Lambda, which we'll show here in a bit. But outside of that, this is a native TFS build using native TFS extensions. So the first sort of customization step is we're going to push this build output up to Amazon S3. So Amazon S3 is AWS's cloud storage solution. It supports object-level storage in a highly scalable, highly durable, and geo-replicatable environment. It's great for storing any different type of assets. For today's demo, we're going to use it as a storage for a build repository to push builds out there so they can be easily obtained by other solutions in the pipeline. The next step of our workflow after it's been pushed to S3 is that we need to let CodeDeploy know that it's ready. And the way we've chosen to do this in today's demo is to illustrate how we can do this using AWS Lambda. AWS Lambda is the AWS serverless code product. It enables you to write application code, application functions, upload them, and integrate and utilize them just as code functions. You don't manage any underlying infrastructure. It becomes an event-driven model. So various events that can be wrapped with other tools can invoke your functions, and you don't worry about infrastructure, the server that runs them, your build, only for the time they run, etc. So this provides a great way to do serverless computing for tasks related to any task, but for DevOps, for example, for controlling our release process. For today's demo, we're actually using Lambda to simply trigger CodeDeploy, more as a demonstration of concept. But this would provide a great step in your deployment process for additional permission gating, additional auditing, or any other steps in your deployment process that need to occur between when a release is ready to go out, but when it actually goes on to new servers. The last point I want to make about AWS Lambda is that it supports a number of programming languages, including C# through .NET Core. So you can begin using Lambda in the serverless model today using a programming language and toolset that you're likely already familiar with. Just to show that, I'm going to open up my Lambda function, just quickly overview it. And really, similar to the web app, just show that there's nothing terribly special about this. This is a out-of-the-box C# function. This is using the Amazon SDKs that were downloaded and implemented via NuGet, defining some simple integration classes, building a code deployment request and notifying where that build can be found in S3, and then pushing that up to CodeDeploy. So we'll use Lambda to trigger to CodeDeploy that a build is ready, and CodeDeploy will take that information, pull that build down, and work to put it onto our servers. CodeDeploy is a complete managed automated deployment engine available on AWS. It allows you to push code up and not worry about any of the steps related to getting that code onto servers. It enables complete automation of installation, configuration, validation of your code as it goes up. It has a number of deployment targets, including EC2, Autoscale groups, Amazon ECS. And additionally, it integrates with the AWS infrastructure, so it can also manage infrastructure tasks and couple them with the deployment task, which we'll illustrate a little bit later. So going back to our build, I want to see if this is completed. So it looks like it has, just to show it went through all its steps, standard build, preparing the package, pushing to S3, and invoking to CodeDeploy and receiving a positive response. Going over to the Amazon console, we'll start with the S3 console just to show that we do in fact have a build pushed up here. So we see a new artifact that was uploaded for this build. And then we want to go over to our CodeDeploy. We should see a new deployment to this deployment group that's likely succeeded. Yep, so we have a successful deployment. And just to further illustrate, we're going to go over to EC2 and find the load balancer that's sitting in front of our code deployment group. We're going to grab that URL and load that into our web browser just to see that our changes have in fact deployed. Pull that up. And there we go. We have our application with our latest changes, including our version number added to the footer. Deployed end to end, just checking our code in, kicking off a build, and sitting back and letting the AWS integration tools get it onto the platform. Okay, to continue on with the demonstration, we're going to go back to our application in Visual Studio. Want to make an additional change here, so we're just going to change that version number again. So we're going to open that file up, go down, fine, just change our version to a V2. Again, we're going to check this change in, go ahead and push it up. And we're going to go ahead and queue up a new build. While that runs, I just want to talk to you briefly about some of the features of AWS CodeDeploy. If you recall, I mentioned earlier that we added a few files to the solution to kind of control how CodeDeploy works. CodeDeploy allows you to hook into a number of lifecycle events that occur during the process of deployment and either be alerted to them or to run custom code during them to do steps. So this enables you to do things like installing your code, doing code cleanup, doing validation, etc. So just to show this, if we have a spec file in the code, the spec file sort of defines where we're going to drop our source code, as well as which hooks we're going to use. And those hook scripts are just PowerShell scripts. So switching over is a configure script. Just a simple PowerShell enables us to install the application, prepare IIS, etc. So these just get checked into our solution. And then kind of switching over, as these deployments run, you'll be able to check and see the status of these steps. So kind of reloading our console here, going into this deployment as an example, if we view events on the server, we'll see all the various hooks that CodeDeploy will run as it's deploying this code. And these are all the places where you can run your own custom code. As the deployment runs, it'll step through a number of these, and they'll start to come back complete. It takes a couple of minutes depending on what each one's doing, size of the application, etc. So we'll kind of run through and let this one complete its work. Okay, and there we go, and these are all complete. If we give just a few more seconds, the deployment should show complete as well. Okay. Okay, the next thing I want to show, I mentioned earlier that AWS CodeDeploy is a complete automation platform around the deployment process, but it's also integrated with AWS infrastructure. This enables CodeDeploy to respond to and even manage infrastructure at times related to deployment. So you can start to step back from infrastructure tasks related to your deployment, configure all that once, and then let infrastructure be automated as it goes through the deployment process. So one illustration of this shows how CodeDeploy can integrate with autoscaling groups to actually respond to health events, such as the loss of a server, disruption in service. So because CodeDeploy and the autoscale group are registered to each other, CodeDeploy will be able to help us respond in the case of a loss of an instance. So to sort of show that, I'm going to go over to the EC2 console to autoscaling. I'm going to find the autoscaling group registered to our CodeDeploy. I'm going to pull up the instances in this group and actually go over to this one, and I'm actually going to go ahead and turn it off. I'm going to terminate it, and this will take it as service, so we'll have no healthy servers available for this deployment. Just to kind of prove that further, we'll go to load balancer, and we'll reload that page just to show that we are in fact down, so we have no servers. So autoscaling will respond as designed to this event by noticing that we've had a loss of server, that our desired capacity is now higher than the available servers in the pool, and it'll respond by bringing up another EC2 instance. So we'll see that happen. It'll notice, and it's launched a new instance for us. And if we kind of tag into this, it'll say, hey, I did this because I responded to a health event. So Autoscale will bring up a new server, but because we're registered to CodeDeploy, we don't have to do anything to that server to get it ready to go. CodeDeploy will notice that Autoscaling has made a change, and it'll automatically configure a new deployment for us. So when this new instance comes up, CodeDeploy will actually initiate a deployment and go ahead and push code down to it. So if we go over to CodeDeploy now, we should see this has noticed that the new server is available and has actually kicked off a deployment. So we have a deployment process to push code to that deployment. So again, completely hands-off, we did nothing. We lost an entire server, and the platform and CodeDeploy brought the new server up and got the code installed for us without us having to do anything. And to further illustrate that, we're just going to go over to our ELB and reload this, and we'll see that our application is back up, and we in fact have that v2 in the footer that we put a number of minutes ago. So the last thing we need to do to enable this to be a true CI pipeline is simply to enable the ability for the build to run when the code's checked in. So to do that, we go over to VSTS and just enable the build trigger to build on check-in. And that's basically it. We can go back to our code, make another quick footer change. And get that change checked in to source. That should be it to initiate a build and kick the whole process off. So we'll go over and just verify that that's building. And there we go. Build's initiated. We'll kick off our deployment process and get us a new deployment into AWS. So just to recap, we've talked about how we can use various tools from AWS, including the AWS Task for VSTS, the AWS SDK for .NET, Visual Studio Tools, combined with platform services such as S3, AWS Lambda, and AWS CodeDeploy to very easily and quickly create a CI pipeline for your .NET applications into AWS using native tool sets and applications and platforms that you're already in use today. So you can quickly implement this in your own environments.
Thanks, Taylor. Hopefully that helped you see that meaningful differences to your current workflows don't have to be massively intrusive, but that sometimes small changes you make to your workflows can have very meaningful positive impacts for you and your team. For some further reading, we wanted to share a few good starting points as well. Just before we wrap up, we wanted to share a program we have found particularly helpful to our customers in the past. We call it an immersion day, and it's something you may have heard about from your AWS account reps before. We run a very similar program. It almost always is done on site at your location, which makes it easier for you to bring larger teams to the event. During the first part of the day, we do some level setting on the cornerstone AWS services, such as EC2, RDS, S3, and DynamoDB. The second part of the day is where things get really interesting. We ask that you nominate one of your workloads currently running in your environment, and we then go through a whiteboarding session to blueprint out what the workload might look like hosted in AWS. By the end of the day, your team will be a lot more familiar with the AWS fundamentals and have some idea of what it might take to move a workload to the cloud. Our experience is that this process helps teams accelerate their initiatives well beyond their most optimistic initial expectations. With that, I want to thank you for spending time watching this presentation. If you have any questions about this presentation, or if you have other questions related to AWS, please reach out to our team. Thank you.